Okay, Harsh, is it okay? Is your
Yes,
internet connection is okay?
yes, sir. Now it's okay, sir.
Okay, fine. So see here, this is the case. So what will happen? Like you have heard about the temperature, like heat flows from higher temperature to lower temperature,
Yes, sir.
and similarly, similarly, the charge will flow from higher potential to lower
Lower
potential,
potential.
and as the wire is connected, as the is connected, the charge will flow. Till then the potential of both the sphere will become become
Same.
same. Suppose you have, this is hot water, and you have cold water. So when you will mix these both the waters, so heat flows, like here charge flows, here heat flows. Till then the temperature of both the cold water and hot water will become same. Here the potential will become same. The charge will flow.
Yes, sir.
Potential become same from this sphere to this sphere. So what is the formula for potential? Uh, we know that the potential of this sphere 1 is given by K Q1 divided by R1,
R1.
and potential for this is given by K
K Q2 by
Q2
R2.
by R2. This is the case. They are saying that find the ratio of their charge densities in terms of their radii.
Radii.
Ratio of charge densities. So charge densities is sigma 1 is the surface charge density of this,
Yes, sir.
and sigma 2 is the surface charge density, means surface charge density. And I have told you that for the sphere we will take only surface charge density. So
Yes.
surface charge density is the charge divided by the surface area. 4 pi surface area is 4 pi r1
R
square,
square.
r1 square for the sphere 1,
Yes,
and
sir.
this will be q2 divided by
4 pi
4 pi
R2 square.
r2 square.
Square.
And they are asking the ratio of charge densities, means sigma 1 by sigma 2 we have to find. Sigma 1 divided by sigma 2 we have to find. Now divide this, 4 pi r1 square divided by q2, 4 pi
R2
r2
square.
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 And when you will solve this, you will get q1
Q1 by Q. 4 pi
r1 square,
R1.
and this thing will go upward,
Go up. So it will be 4 pi R2 square by Q2.
q2, and this 4 pi and 4 pi cancel.
Yes, sir.
Okay, now we have q1 by q2, sigma 1 by sigma 2, we have q1 by q2 into multiply, this is the multiply, and we have
R2
r,
square
yeah, r2
by
by
R1
r1 whole square, you can say.
whole square.
And from here we know that the v1 is equal to v2.
Yes, sir. Potential is equal.
v1 is equal to v2, so put the value of k q1 divided by r1, k q2 divided by r2. I need some more space. So from here we can find the ratio of q1, k is cancel out.
Yes, sir.
So from here we can find q1 by q2. This will become r1 by
R2.
r2. So we will put the value of q1 by q2 as r1 by r2. So sigma 1 by sigma 2, Q1 by Q2 is R1 by R2, and this is R2 by R1 square. So I can write this 2 times, R2 by R1 square.
R1.
Now
Yes.
R1 is cancelled from here,
R1.
R2 is cancelled from here. So sigma 1 by sigma 2 is equal to
R2
R2 by.
by R1.
This is little bit tough question.
Yes, sir.
Yeah. And you should note it down for your examination purpose. This is a question of
Sir,
CBSE.
yeah. Can you
Yeah,
scroll?
I am just zooming it out.
Okay.
Okay, fine. This is a very good question.
Second scroll down. Second scroll down a little bit more.
Scroll up or scroll down?
Down, sir, down.
Down. Okay, very good.
Yes,
You are
sir,
writing very fast today. You are getting 7 marks out of 10.
Yes, sir. Okay.
That is quite good. And remember that sigma is the surface charge density. Sigma is the surface charge density.
Yes, sir.
Surface charge density.
Done, sir.
Okay, Harsh. So we are just moving on our topic. So you performed well in the test, and current electricity chapter.
Yes,
We have
sir.
discussed drift velocity. We have discussed the drift velocity, basics of drift velocity. So what I have told you, just I am reminding. Suppose this is the conductor initially we have. This is the conductor initially we have, and this conductor is surrounded by air, and
Yes, sir.
this conductor is surrounded by the, you can say, the temperature. This conductor
Yes.
means I am sitting in a room, and this conductor is in a room, in this room, and there is some temperature of this room. Due to the temperature, the electrons inside the conductors getting the heat energy, and due to the heat, or you can say thermal energies, they are having the thermal velocities, and they are moving with thermal velocities in random directions. So there is a random motion, and they have the random velocities, and when we will take the average of all the velocities, then we will get the zero. And after we have applied the electric field, the electron will experience a force due to the electric field, and the electron then move with the drift velocity. And I have told you, whenever a charge is placed in electric field, it experiences a force F is equal to QE, and
Yes, sir.
M is the mass of electron, F is the force on each electron. So I am writing force in the vector form, and force is also given by mass into acceleration. We have calculated the acceleration of electrons. We have calculated the acceleration of electrons. Now we have calculated the acceleration of electrons. And I have also told you that in a conductor, along with the electrons, there are positively charged ions also. There are positively charged ions also. So what will happen? Now the electron will have the acceleration, but when it will move, when this is electron, and this electron is moving in this direction, this electron will collide with positively charged ion. Positively charged ion,
Yes,
and
sir.
after collision, there is a change in the momentum of electron, and due to the change in the momentum of electron, this is the electron now. After the
Yes.
collision, the electron will go in this direction, and after this, maybe the electron will go in this direction, and again it will collide with some ion, and again it will move in some another direction. So means electron will moving towards the positive terminal of the conductor, and also colliding with the positively charged ion. So I am just writing here, electron will collide with ions after one collision, or you can say electron will collide with ions. Okay. And time taken in the collision, I am representing the uh, as the relaxation time. So from here to here, time taken, I am taking tau 1. Why tau 1? Because I am supposing this is the electron 1,
Yes, sir.
and we have n number of electron. So
Yes, sir.
tau 1 is the relaxation time. Relaxation time for electron number 1. Electron 1. And what is the relaxation time? The relaxation time is
The time between two successive collisions.
yeah. Relaxation time. Time interval. Here, see here are the two collision. One collision here, and
Yes,
after
sir.
this electron is going in this direction, and due to the
Yes.
force it is going in this direction, and then this is the second collision. Time interval between two successive collision.
Yes, sir.
Successive collision of electron with ion, of electron with ions. So and tau 1 is the relaxation time for electron 1. Similarly, you can say tau 2 is the relaxation time for electron 2, tau 3, tau 4. So tau 1, tau 2, tau 3, and we have n number of electrons, so we can take tau n. These are the relaxation times. Relaxation time. And sorry. What is happening? So is the relaxation time. I am just modifying this. What is happening here? We have, oh, it's a drop. Yes. Hmm. This is the acceleration. You will get from this equation, and this is the electron number 1. And what will happen after the second collision? This electron will have some velocity, final velocity in this direction. And initially also, this is initial condition of electron, and initially it has
Yes,
the
sir.
velocity u1. We have discussed this is the initial velocity. This is the initial velocity of electron, and this is the final velocity of first electron. This is the initial velocity, this is the final velocity, and this is the relaxation time. And if you will apply this equation, V is equal to U plus AT in the vector form. V is the final velocity, U is the initial
The
velocity,
initial velocity,
A is the
acceleration,
acceleration, T is the
T is the
time.
time. Yes.
So for electron 1, final velocity is V1, initial velocity is U1, acceleration is A,
A,
and time is tau 1.
tau,
Similarly, we can write for electron 2,
U1, U2, sorry, U2 plus A gives tau 2.
and accordingly we can write for nth electron. Final velocity for nth electron Vn, V suffix n, Un plus acceleration will remain same of all the electrons tau n. Now if I am taking the average of V1, V2, V3, Vn, I am taking average of final velocities V average. I am representing, this will become V1 plus V2 plus V3 plus, we have n number of electrons divided by n. N is the number of electrons. Now we will put
Yes.
the value of V1, V2, V3 here. This value we will put here. So you will see V average is equal to V1 is equal to U1 plus A into tau 1. This is V1. V2 is equal to U2 plus A into tau 2, and V3 is U3 plus A into tau 3, and now you can write for so on, and Un plus A into tau n divided by n. I have written this in form of this. So from here you can write V average is equal to U1 plus U2 plus U3, U1 plus U2 plus U3 plus Un U1 plus U2 plus U3 and accordingly. And here you will take, you have A tau 1, A tau 2, A tau 1 plus A tau 2 plus A tau 3, you will take A common, then you will have tau 1 plus tau 2 plus tau 3 plus tau n, and this is the n, so we can divide this with n, and also we can divide with this n. And what is this? This is the initial average velocity. See here, this is u average, u1, u2, u3 equal to 0. This term is 0, so v average is equal to, this is u average, this whole value is u average, this whole value is u average and plus acceleration, and this whole value is the average relaxation time tau, and this is average relaxation. This is the relaxation time for one electron, relaxation time for second
Yes, sir.
electron, and if you will take the average, then this will become average relaxation time for all the electrons. So you will write this you will write as tau, and you know that u average is equal to 0. This term is 0. This is A into tau, and this is 0. So A is minus E tau divided by m. A is E by M and multiplied by tau. And you have V average that is equal to minus E tau divided by M. And this V average is the drift velocity represented by Vd, E electric field, tau divided by M. This is the expression for drift velocity in the
Sir,
vector.
what is E?
E is the charge on electron. I will write everything here. Vd is drift velocity.
Yes, sir. E is electric field.
Yeah. E is
Tau is
the
relaxation time.
E is electric
Field. Tau is relaxation time.
Electric field. Tau is the relaxation time, or you can.
And M is the mass of electron.
Yeah. Relaxation time. E is charge on electron. Charge on electron. M is mass on electron.
Yes, sir.
Mass of electron. So note it down, please. This is the derivation. This derivation may be appear in your examination.
Yes, sir.
Yeah. This is very beautiful concept of drift velocity.
Yes, sir. Scroll down.
Harsh, I am just coming in 1 minute, 1 or 2 minutes. Okay.
Yes, sir. Yes, sir.
Noted.
Yes, sir.
Completed.
Yes, sir.
Okay, fine. So this is the derivation of the drift velocity. You feel this little bit complicated, quite complex, but when you will do this step by step, this will be very, very easy. And you will remember the formula, this formula. Please remember the formula of drift velocity. This is the formula of drift velocity. Now, if I want to write the drift velocity in the I mean to say that if I want to write the drift velocity, magnitude of drift velocity, that will be E tau divided by m. So, and E is the charge of electron, E is the electric field applied, tau is the relaxation time, m is the mass of electron, V suffix d is the drift velocity of electron. Drift velocity of electron. So there is one more point I want to write here. On increasing the temperature, on increasing the temperature, electron will collide fastly with the ions and relaxation time of electrons decreases means you can say tau decreases. So see here, if the tau decreases, then drift velocity should also be decreases. Tau
Yes, sir.
decreases.
Yes, sir. Yes, sir.
Yeah,
Definitely also
this is
decrease.
directly proportional. So drift velocity will also decrease in case of conductor. So why the relaxation time is decreasing? Because on increasing the temperature, the collision will be very fast of electron. Collision will be very fast of electron. The collision of electron will become very very fast. Means time for relaxation will decrease.
Yes, sir. Yes, sir.
This is very obvious. If there are certain, you can say, if there are 10 people in the room, okay, if there are 10 people in the room and they are relaxing,
Yes, sir.
and suddenly mm, the temperature of the room, somehow the temperature of the room increases to 100 degrees centigrade. Like 100 degrees centigrade is the boiling point of water.
Yes, sir.
So now rest, you can imagine the condition of the room. Those person will walk, means move here and there in the room like this
Yes, sir.
because of the temperature. They will try to escape out from the room,
Yes, sir.
but the room is locked. So what will happen?
Relaxation time decreases.
Earlier they were relaxing, but now you can
They're not. They're
imagine.
running.
Yeah, means relaxation time. The same the case is for electron.
Yes, sir.
Yeah. Okay, uh, now we will drive a relation between the current and the drift velocity. Relation between drift velocity and current. For this, I am taking a conductor, cylindrical conductor. I am taking a cylindrical conductor and I have connected this conductor with some cell or battery. So inside this, the electron will move in this direction. This is positive end of the conductor. This is the negative end of the conductor with drift velocity. We have discussed this. And L is the length of the conductor and A is the area of cross section. A is the area of cross section of conductor. So for this conductor, if you will find the volume of the conductor, volume is area into length. Volume is this. Volume is area into length. And if n, small n, is the number of free electrons, this is electrons per unit volume. Means in 1 meter cube, in unit volume, there are n free electrons. And if you want to find total number of free electron, total number of free electrons in conductor in 1 meter in 1 meter cube there are n number of electron. In Al meter cube there are NaL electron.
number of electrons.
Yeah. And this total number of free electron is represented by capital N.
N.
So capital N is equal to small n into A into L. This is the equation 1. And one thing more, this electron is moving from negative to the positive terminal in some time delta t. I'm just
Yes, sir.
writing here. Electron is moving from negative to positive end in some time delta t, and L is the length of conductor. So drift velocity can also be written in terms of L divided by delta t. This is drift speed. This is drift speed. Drift speed means drift velocity without direction, or the magnitude of drift velocity is known as drift speed, L by delta t. Okay. So this is another expression, equation 2. And we want to, if we want to find the current, if we want to find the current, then we know that current is equal to charge divided by time. And what is the charge means? Charge flowing. Charge, what is the charge flowing? Means charge is flowing in this direction. Delta Q charge is flowing in this direction. Charge is what here? Electron. Electrons contains the charge. And on one electron, there is E charge. Then on an electron, means on capital N electron, there is, you can find delta Q as total number of electron n into charge on electron, and delta Q is n is equal to small n Al divided by, oh sorry, you will multiply this with capital N also.
Capital N.
Yeah. And this is delta T. See here, L divided by delta T is drift velocity, and A Vd into N. So relation between the current is A N E Vd. This is the relation between the current. And if the current will flow from positive terminal to negative terminal.
Negative term.
Like this.
Yes, sir.
Delta Q is charge flowing through the cross section. This is conductor. This is the area of cross section, and this area of cross section is same throughout the conductor.
Yes, sir.
Because this is a cylindrical conductor. This is volume. Of this conductor. And n is the number of
Yes, sir.
free electrons per unit volume of conductor. All the things here are for conductor. Length is L. The length is for length of conductor. L is the length for conductor. Capital N is the total number of free electron in conductor. And for the drift speed, you can write this is the magnitude of drift velocity. Magnitude of drift velocity is also called drift speed.
Second scroll down.
Yeah. So this is the end. This is
Oh,
the
yeah,
end.
it's the end. Okay.
Yeah.
Done, sir. Done.
Done. Got it? How you will drive? First you will calculate. Actually, you want to find the current here. I'm just
Yes, sir.
summing it up. Current is delta Q by delta T.
Yes.
And somehow we will find the charge delta Q. And delta Q is due to the electrons. And
Yes, sir.
if we have somehow find the total number of electrons. So N is the number of electrons per unit volume. And
Yes, sir.
when we will multiply this with the volume, this will become total number of free electron. This will become total number
Total
of free
number.
electron. And charge on one electron is E. And charge on an electron, this is capital N. NaL is capital N, is E.
Yes, sir.
This will become delta T. And Ly delta T is Vd. This Ly delta T is Vd. So
Yes, sir.
and when you will divide this side delta T, then this will become I is equal to A and E Vd. So I am writing the symbols here. A is the area of cross section of conductor. Area of cross section of conductor. N is the number of free electrons per unit volume of conductor of conductor. E is the charge on electron. Charge on electron. V suffix d is the drift velocity of electrons. drift velocity of electrons. So the relation between the current and the drift velocity is equal to current I is equal to A area and number of electron per unit volume, E electric field into drift velocity.
Yes, sir.
Yeah. Now we will have Ohm's law. Very famous Ohm's law.
Yes, sir.
Do you know what is Ohm's law?
V is equal to I R.
Wrong. This is not Ohm's law. Ohm's law is the something different. V is equal to IR, you can say a special case of Ohm's law. When you kept the temperature and other physical quantities,
Yeah. Yes. Special case of Ohm's law.
you have to say this statement also. If temperature and other physical quantities like length and area, area we will always talk about the area of cross section. Area, if the temperature and other physical quantities like temperature and area are kept constant, means if the temperature of a conductor, area of the conductor, length of the conductor is not changing, then the L is the length of the conductor, A is the area of cross section of the conductor, and T is the temperature of conductor.
Yes, sir.
So generally it happens. Generally it happens. See, this is the this is the conductor. Here this wire is a conductor.
Yes, sir.
See, is the length of this wire is changing? Not changing, na?
No, sir.
Area of cross section is not changing.
No, sir.
Temperature of this room means temperature of this conductor is not changing.
Yes, sir. Not
So
changing.
generally it is followed. So in this case, you can say this is a conductor. So in this case, you can say potential difference across ends of conductor is directly proportional to the current flowing in the conductor. From here to here is Ohm's law.
Yes, sir.
If someone is asking you what is Ohm's law, so you will say if the temperature and other physical quantities like length and area are kept constant, then potential difference is directly proportional to current. That is Ohm's law. That is Ohm's law. And you cannot say potential difference is always directly proportional to current. Okay. So this is the whole thing is Ohm's law. And again, this is the conductor. Potential difference or voltage. Potential difference is also known as the voltage. So I am representing potential difference with V, that is directly proportional to current I. When we remove this proportionality sign, we will get a constant R. Then we can write this as V is equal to IR. V is equal to IR, and R is known as the resistance of conductor. Resistance of
Conductor.
R is the resistance of conductor. And if you will plot the graph of resistance versus, voltage versus current, then you will get a straight line graph. You will get a straight line graph. But this graph can be like this also. This graph can be like this here also. If on vertical axis there is voltage or potential difference, if on horizontal axis current, this is the graph. And if this is making an angle theta, then slope of this graph is tan theta, and this slope is equal to resistance of conductor, and that is constant. So this is a straight line graph. So you can say graph of V versus V, is V is voltage here, or the potential difference here, not the velocity. Potential difference versus current is a straight line. Straight line passing from origin. Passing from origin. Please note it down. This is the Ohm's law.
So can I scroll down, sir?
Very good. You have written already.
Yes, sir.
I have told you earlier also, this chapter is very, very easy as compared to electrostatics.
Yes, sir.
This is the origin, this point.
Sir, what is the straight line?
What?
What is that? A straight line coming from origin?
Yeah, this straight line is starting from origin. Okay. Have you not done the experiment of Ohm's law in your school?
No, sir.
In your school, there is a lab of physics.
Yes, sir. There is that.
There is a lab, but actually, okay, I got
Sir,
it.
because last year it was COVID, so half year school was there, half year.
Yeah. Understood. No problem. You can understand this thing from the graph also.
Yes, sir. So done, sir.
Now we will define the resistance. What is the resistance? We will define. Resistance is the hindrance in the path of current. You can say it opposes the flow of current. In simple words, you can say resistance opposite the opposes try to reduce the flow of current, opposes the flow of current. And why this resistance came into existence? Because of collision of electrons with ions. We
Yes,
have
sir.
discussed. Cause of resistance is if the electron will travel smoothly, there will be no resistance. But in the path of electrons, there are ions also. So there will be some reduction in the current, and that is given by the resistance. Cause of resistance is the collision of electron with ions. We know that resistance is equal to potential difference divided by current.
Yes, sir.
But now you will see there is a different form of resistance also. Microscopic form. Microscopic form of resistance. Suppose if you have a conductor here, this is again a cylindrical conductor, and I am taking L length. Area of cross section is not changing throughout the length, that is A. Okay. So we know that we have just derived the relation between the current and the drift velocity. I is equal to A N E V D. And if I have applied electric field across the ends of this conductor, and V is the potential difference across the ends of conductor, and this is the positive end, if this is a negative end, if E is the electric field generated inside the conductor, E is the electric field generated inside the conductor. So you can write electric field is equal to potential difference divided by length. You can write this. So I is equal to A N E. Drift velocity is E tau divided by mass of electron.
Yes, sir.
From here, I can write A N and E into E square, and here we will have tau divided by M, and instead of E I can write V divided by L. Now take V this side. I divided by V is equal to A N E square tau by ML. A N E square tau by ML. But we know that resistance is equal to V upon I. Potential difference divided by current. So reverse this. This is I upon V.
Yes, sir.
Is this when you will write V upon I, then you will write ML first. After you will write A N E square tau. So this is the another formula for the resistance.
Yes, sir.
Very, very important. So write it down.
Done, sir.
10. Good. Now we have the formula of resistance. We have the formula of resistance as R is equal to ML divided by A and E squared tau. We have this formula of resistance, and this can be written as potential difference divided by current. So now we will use this formula. So from here, and m is the mass of electron.
Yes, sir.
Can the mass of electron will change on increasing the temperature?
Mass of electron change.
Mass
Yes,
of
sir. Yes,
electron.
sir. It
No,
can
no,
change on
beta.
temperature.
No, beta. Mass can never be
No,
changed.
mass of electron can never change. Mass of something else.
No. The mass cannot change. Suppose this is a mouse. This is a mouse.
Yes,
And
sir.
if you burn this mouse, then mass will remain same, na? If you
If we
increase,
burn the mouse.
if you
Yes,
will burn
sir.
the mouse, it will become ash. And
Yes, sir.
if you will calculate the mass of the ash and mass of this mouse, then you will get the same mass.
Yes,
So
sir.
mass can never be changed, and charge on electron
It's constant.
can never be changed. So mass
Yes,
and
sir.
this quantity can never be changed, but length can be changed. Length of the wire can change.
Yes.
Area of the wire can change.
Yes, sir.
Number of electrons per unit volume of the wire can change by changing the material. Relaxation time can change. So you can say that resistance depends on number one, resistance is directly proportional to length. See here, directly proportional to length. Resistance is inversely proportional to area of cross section.
Yes, sir. Resistance is inversely
Yeah.
proportional.
1 by
Okay.
n,
Yeah.
small n, and resistance is again inversely proportional to relaxation time.
Yeah, relaxation time. Sorry.
Or you can say temperature also, because relaxation time depends upon the temperature. So you can say on the temperature also. Just wait for Azan. I'm just waiting for Azan. Okay, Azan. Oh, okay, sorry. Okay, Harsh. R
Yes.
is directly proportional, inversely proportional to small n. And see here, this R is inversely proportional to tau.
Yes.
L is the length, A is the area of cross section, and this n is the number density, or you can say number of electrons per unit volume. This n depends upon material. Depends upon material. For copper, the value of small n is different. For silver, the value of small n will be different. And this relaxation time depends on temperature. We have discussed this. If we increase the temperature, the relaxation time for the electron will decrease. Okay. So this is all about the resistance. What is resistance? How we can write the microscopic form of resistance, that is R is equal to mLA Ne square tau, and the dependency of resistance on different factors. Now we will have the next topic, resistivity. Have you noted this down?
Yes, sir.
Now we will have the next topic, resistivity. Resistivity. So I will derive resistivity with resistance. See how I will do this. Resistance is equal to ml divided by A N E square tau, and I can write this m divided by Ne square tau
Yes, sir.
multiplied by L by A, and this term is the resistivity. Resistivity, and this resistivity is represented by rho.
Yes, sir.
This is rho, RHO rho.
Yes, sir.
RHO rho. This is resistivity. So I can write resistance is equal to, this is rho,
Yes, sir.
L by A,
Yes.
and rho is equal to m upon Ne square tau. So now see here, we have rho is equal to m upon Ne square tau. So rho is depending upon mass of electron and charge of electron. So
Yes, sir.
mass of electron is constant, charge of electron is constant.
Constant. Electron is constant.
Always constant, means on increasing the temperature, decreasing the temperature, if you will half the length, if you will double the length, if you will break the conductor, no problem. Mass and charge will remain same on electron.
Yes, sir.
Always. So you can say that resistivity rho is depending upon the small n and tau.
Yes, sir.
So small n depends upon the material and tau depends
Yes, sir.
upon the
Material and
temperature.
temperature is tau.
So you can say resistivity
Temperature.
depends on, yeah. So you can say resistivity rho depends upon n and tau, small n and tau. It means that small n depends upon the nature of material, and temperature.
Yes,
So
sir.
you can say resistivity depends on nature of material and temperature. Depends on
Temperature.
nature of material means copper have different resistivity, aluminium have different resistivity on nature and
Temperature.
okay. And one thing more I want to tell you, the unit of resistance is ohm.
Ohm.
Yeah.
Yes, sir.
Unit of resistance is ohm.
Ohm.
Ohm, HM, ohm. SI unit. For resistance, SI unit resistance is potential difference divided by current.
Current.
Unit of potential difference is volts.
Volt.
Unit of current is
Ampere.
yeah, ampere. And this volt per ampere is known as OHM, ohm, and this
Ohm.
is represented like this.
Yes, sir.
Please write this down.
Done, sir. Wrote it.
Very good. And if we will talk about the SI unit of, and see here, this resistivity only on depends upon the nature of material,
and temperature.
nature of material and temperature,
Yes, sir.
not depending upon the area and length.
Yes, sir.
Length and area. Suppose
Yes,
if
sir.
you have a copper wire of length 1 meter, if you have again a copper wire of 10 meter, okay. So I am saying if rho1
Yes,
is
sir.
the resistivity of this and rho2 is the resistivity of this, so what is the relation between rho1 and rho2? If the temperature and the here this is a copper,
Yes, sir.
and the temperature of this wire, copper wire, is T, not changing, and this is
Yes,
again
sir.
a copper wire and temperature is not changing. And
Yeah.
if rho1 is the resistivity of this, so what is the relation between rho1 and rho2?
Sir, rho1 is equal to rho2, right?
Very good, very good.
Because
Rho1,
length and
yeah, because resistivity will not depend
Yes.
on the area and the length, it will only depend upon the nature of material. Here nature of material is same, both the material are same, and temperature
Yes,
is
sir.
also same. You can add this point
Yes,
here.
sir.
No problem, no difference upon the. So if I am talking about the SI unit, so you know that rho can be written from here RA divided by L.
Yes,
Rho
sir.
can be depend as RA divided by L. The unit of resistance is ohm.
Ohm. Ohm.
Unit of area is meter square.
Meter square.
Unit of length is meter, and this meter square is cancelled by meter.
Meter.
So SI unit will be ohm meter.
Ohm meter.
Yeah. And if I want to define the resistivity, then how we will define the resistivity?
Yes, sir.
I have just write the formulas only. I have just not written the
It is the
definition.
amount of resistance per unit area.
Yeah, you can say like that. You are 50% right. So definition.
Yes, sir.
Definition will be resistivity is the we have formula. Actually, we will make the definition. we have resistance is equal to resistivity into length divided by area. If you will take a length of 1 meter and area of 1 meter square, put value of rho into 1 divided by 1.
Yes, sir.
So what is resistance will become resistivity. So definition of
Yes, sir.
resistivity is the resistance of conductor,
Per unit area.
resistance of conductor of length 1 of you can say of unit length and unit cross section area
Yes,
of
sir.
unit
Of unit
length,
length and
yeah, unit length and of unit length
unit cross section
resistance of
area.
unit means 1 meter cube or
Yes, sir.
centimeter cube or decimeter cube or millimeter cube. Resistance of conductor of unit length and
Unit cross section area.
unit cross section area.
Yes, sir.
Write down.
Sir, done, sir. I wrote.
Very good. Now we will have conductance.
Okay.
And this conductance is represented by capital G, and this conductance is equal to 1 upon resistance.
Yes, sir.
And SI unit of conductance, you can you calculate the SI unit of conductance?
SI unit of conductance.
Yeah, of course we can calculate.
Yes, sir. Of course.
This 1 by ohm means ohm inverse. And this ohm inverse can also be written OHM inverse. And when you will inverse, this is OHM, now this will become MHO.
Yes, sir.
Oh, time is over. I am thinking, okay, I am having a one more class, Harsh. So have you written this?
So just a moment. Sir, just a moment. After conductance.
Yeah, you can write this, and I am having one more class after this. So this is very easy chapter. If you will study
Yes,
this chapter according to a planning, according to a strategy, and if you will revise the notes, then in the last chapter you will got
sir.
7 out of 10. In the test of this chapter, you will get 10 out of 10.
Okay, sir.
Written?
Done, sir. Wrote it.
So Harsh,
Yes,
that's all
sir.
for today, and
Okay, sir.
I will give you the assignment also, and please check the
Yes, sir.
portal and please solve the
Yes, sir.
question
Yes.
of
I'll check.
assignment. Okay. Okay,
Yes, sir.
Harsh.